Let's move on from addition and subtraction, look at multiplication. There's only one word that I need to tell you to do this problem, that's distribute. If I tried to distribute here, yeah, pretend that this square root of 3 isn't even there. What is the square root of 2 times the square root of 5?
Square root of 10.
It's the square root of 10. Magic hands, right? Plus what?
The square root of 6.
When I distribute here, see, the only way that you can multiply the 2 times the 3, the only way that you can multiply these radicands is because they have the same index. We did an example like that, remember on Monday? So here, I've got the square root of 10 plus the square root of 6. Can I combine these guys?
Yeah, no.
Wait a minute, we just got done talking about like radicals.
Oh, yeah, no, you can't.
They're the same index, right?
But not the same radicals.
Not the same radicand. So addition is very, didn't we talk about how addition and subtraction are, they're like the racist of math?
So would we go further now and get the squares of those?
Well, let's see, can 10 break down at all?
Yeah.
That's 2 times 5, 6 is 2 times 3, does that help me out?
No.
No, we can't do
We're
anything.
done.
See, addition is not the fun guy to play with because he's very restrictive. Like, he can only combine like terms. You gotta look just like to be together, right? You know who doesn't care? Do you know who's progressive? Multiplication. Does multiplication require like terms? No.
He doesn't play by the rules.
I feel like there's a song in there.
We'll call it racist math.
So wait, so Courtney's gonna hum in the background of this, creating the theme music, the theme song for this video. That's cool. No problem there.
She's going to be the one listening to it later, so.
He's like, hey babe, that's me. Listen, he got me. Now, when I do this problem, is it any different than the last one?
No.
No, so let's go ahead and distribute here. What do you get?
Square root of 18.
I get the square root of 18, then what?
Minus.
Square root of 6.
Minus the square root of 6, do y'all agree?
Yes.
Yeah, but we can do something with that now.
We can definitely do something with 18. Look at number 3 from your quiz.
We can do 2 and 9. Oh, I'm sorry.
No, you're right. 18 does break down as 2 times 9, so this guy is, in the words of some of you, sweet, right?
Bring the 3 out.
What's the square root of 9?
3,
Who stays inside?
2.
What about the square root of 6?
No.
He's the same losery guy that we had up here, right?
Be a loser.
Boy, you're okay. Can I do anything with these square roots? Can I combine those?
No.
Nope. So we're done.
Can you do one where the index is not the same?
I did an example of that. Look at the videos from Monday or
But I want
Friday.
you to do it now.
I'm not going to do that now because you're not really going to see that. We're multiplying here. Typically we'll have the same index.
Different page.
Okay?
And we're going to do the tests where they don't have the same index.
No. But what we see in class is what you're going to see on the test.
You sure?
Do it again.
Okay.
Let's make things a little bit more challenging, right?
No, that's not.
Yeah. I mean,
So if I've got this, is it really different from the other problems that we were just doing?
Probably not.
No.
No.
how are you gonna? Excuse me. Let me speak perfect English. How are
Thank
you
you.
going to distribute that 2 square root of 3 to 5? when
Okay,
that's
well let me
not
show you
a-
this. If I have 2x times 5 plus 4x, can you distribute that? You know you can, because you know that even though this guy doesn't have an x, I told you multiplication is nice. You don't have to be like terms. You would have 10x plus 8x squared with properties of exponents, right? So coming back to this example that's in green, when I distribute, what do I get here? I get 10 square roots of 3, because you have to understand that in that product, in this product, you've got 3 factors. You've got 2, you've got the square root of 3, and you've got 5. you multiply together the things that you can multiply together, which would be the factors of 2 and 5, because they are both outside of the radical. 2 times 5 is 10, and the square root of 3 is right here. When I distribute here, what do I get?
8 square roots of 3.
I don't get
Oh,
8
with
square roots of
square
3. Look up here. I did 3, square root of 3 times the square root of 6, and what did I get? I got 18, didn't I?
Yes.
So then what am I going to get here? Aren't I supposed to multiply those
9.
radicands?
Oh,
I get 9, but am I done with this problem?
no,
Why not?
because that's a perfect square.
I will break this down, because what does this guy equal?
3.
That guy equals 3, right? So then what is my answer here?
10 square root of 3 plus 11.
11.
Oh, I'm sorry.
Let's see.
Never mind.
What's going on between
Oh, I'm
8?
sorry. I'm sorry. 24.
This is
Sorry.
multiplication, right?
I'm sorry.
So these guys, you're okay. These guys are connected through multiplication, so I end up with 24. Do y'all agree?
Just 24?
I got tripped up.
What else would it be? What is the square root of 9?
3.
Just 3. And if you're not sure about this, just think about this over here. If I have 8 times the square root of 9, it's almost as though these guys could be in parentheses, right? So it means that's 8 times, what is the square root of 9?
3.
He's 3, free and clear, right? Just straight up, he's 3. He doesn't have anything left inside the square root, and so that's why we end up with just 24.
Why wouldn't you have like 3 square roots of 2?
Where would I have 3 square roots of 2 from?
Or 3 square roots of 3 now?
Oh, because
What
you
is
were
the
trying
square
to
root of
break it
9?
down?
3.
Right.
But like when we did it over here.
What was the square, what was the radicand? That was 27 though, right?
So it wasn't, okay, so it was a multiple of that. Okay.
So this is what we have here. Can I combine these guys any further?
No.
One has a radical, one does not. So we are done.